really quick. Let's multiply those out. So distribute the x, distribute the 2, combine like terms. Do you have a J? Okay, what are you grabbing the back of the meter school? Do you need no packet? I don't want to do this. I'll grab it from the bottom back. Yes, you sit right behind Brian, next to Brian. And then David, you're actually in the wrong seat. You sit there diagonal behind 809. Can you move up, please? A little bit closer to the board. All right, what does that look like?
Looks like math.
That's accurate. Looks like math.
I'm sorry.
No, it's fine. I'd rather you guys joke around than just sit there angry to be here. If you're angry to be here, at least you're masking it pretty good today. Yeah. Okay, then what? So we multiply this through. We get something that's 4 terms. Now, if the goal was factoring and I gave you this, what would you do with it? If the goal was factoring and you saw 4 terms, you should think to do what? Grouping, right? And if I were to group it and factor it, you would end up getting exactly what this is right here. We're actually undoing the factor, and undoing the factor is called multiplication. So x squared minus x minus 6. Our goal is to get from here back to here. And the key step in the middle is to force it to have 4 terms so that you can group it. Okay? Because when you factor things, you're able to solve them, and that's kind of where we're headed, is to be able to solve things. So we need to factor them first. That's where the joking crosses the line, Jake. Okay. Barney, direct him to the backboard.
Dude, look at the backboard, my man.
Okay. So, what do? We need to take something that looks like this and force it to have 4 terms so that we can group it. So, step 1 would be to play the multiply add game. The other game is guess and check, which is a little bit, well, yeah, a little bit harder. Okay, here's how I set up the multiply add game. Some teachers, I do it like this. Some teachers do it like this. Right? I know. So I'm looking for this is like the key part of today. Will you please make sure you're watching? I'm looking for 2 numbers, look at the outside pieces, that multiply to 1 times 6, which is 6. So the multiply is multiply to the outside. Okay. Thank you. And then it has to add to the inside. Some teachers call it multiply to a times c, which is a is first, c is last, and we'll add to b. So it'd have to add to the -7. Or what two numbers multiply to 6 and add to -7? This is where that practice came in from last time. So think about it for just a second. What two numbers would multiply to 6 and add to -7? Raise your hand if you know. Okay, this is for you. Raise your hand if you know two numbers that multiply to 6 and add to -7. All right, Ryan, what is it?
-6 and -1.
-6 and -1. -6 times -1 is 6. -6 plus -1 is -7. So these are the two it's not a highlighter. These are the two numbers that you'll use to make the 3-term problem, this right here, go into a 4-term problem. And as soon as I can get it to 4 terms, we can group it. So what we do is we take our two numbers, -6 and -1, give them the variable n, and step 2 is to split the middle term into 2 pieces. So if you split that middle term into 2 pieces, how many terms would you have total in this expression? 4. So this becomes -6n and -n. We get that from the two numbers we got from the beginning. Great. This n squared just comes down, and this 6 just comes down. Now we're reviewing this. If you're not catching on initially, that's fine. Hopefully after a couple, it will come back to you. But now that we have something that's 4 terms, what can you do? We're going to group it. Okay, take a minute, group it for me. You did that last time. I need to grab a charger. You know, I should. I wasn't here yesterday, so. I mean, I was in the one of the conference rooms all day at the meeting, but. Group it, go. Are you done?
No.
Group it, group it.
Hold up.
It's so worth it. I love it. I was talking to a mom one night, and she was talking about how, I don't know, how enthusiastic I am about my subject. And I was like, yeah, it's a little embarrassing sometimes. And she said, own it. And I said, I do. I love it. Every time I say group it, I think of that though. So every once in a while, I just have to sing it. Okay, how do we group? Group the first two, group the last two. Don't forget there's a little plus sign in here so you don't confuse yourself and start to multiply. From the first group, what do they have in common? An n. What are my leftovers? Wonderful. From the second group, what do they have in common? A -1. Very good. And what are my leftovers? The negative comes out and the plus turns into a what? A minus. Again, I know that I'm on the right track because those two parts are the same. So it comes out front and out back and -1. And now they're grouped. If I wanted to multiply them out, I could see that this would be equivalent to that. And in the whole math scheme of things, you need to know how to do this so that you can solve. And that's coming up. I'm pretty sure Unit 6 is either solve or Unit 7 is solve. I can't remember if we'll do it in December or if we'll do it in January. But that's coming soon, being able to solve something. We got to do it. Okay, let's do it again. Part B. What's the first step? Yeah. We are looking for two numbers that multiply to the outside. 1 times negative 56 is negative 56. And they add to the inside, which is what? Negative 1. Now, we did happen to play this multiply add game when we were doing questions from 5. Are we in Unit 5? You guys, that means we're like a third of the way through the school year. Is that weird? How old are you?
Wait, so does that mean we only have?
Oh, weird.
Does we only have 15 whatever you call units?
Well, since we finished Unit 4, we have 12 units.
We have in general.
We have 12 units in this course. We're in Unit 5. That feels good, right?
It does.
I mean,
Not fast.
not fast. Hey, it's gone fast. Before you know it, you're gonna be like, oh crap, I'm gonna be a senior.
I'm ready.
It's an exciting / scary moment.
That is not an exciting or scary moment. It's just another year's.
Oh. Graduating's not terrifying for anybody?
Oh no, I'm very happy to graduate.
Oh.
I do not.
I don't want to go
I don't
through
want
that
to be
long.
graduating.
All right, what multiplies to negative 56 adds to negative 1? Jake, are you still with me?
Maybe.
Cool. What multiplies to negative 56 adds to negative 1? Did we do that last time or do we want to go through it? So just look at what multiplies to 56. 1 and 56. 2 and 28. 7 and 8?
Yeah.
7 and 8. We did that on number 28. Very good. Now, which one would have to be negative in order to get the negative 1? The 8 would have to be negative. Great. So, step 1 is to play the multiply add game. Done. What's step 2? Put it into the equation. We want to take that middle one and break it up into 2 steps. Does it matter which one comes first? No. Your work might be a little different, but the final answer will be the same. So, let's break it up into 2 pieces. So I've got m squared just comes down, and then each of these needs an n, plus 7, or m minus 8m minus 56. And once you have it in 4 terms, what do you do? Group it. None. Okay, I'm sorry. Group it. Do you have your notes? Grab a new one. Okay, cool. If you ever don't have something, it's just right here. There you go. If it means you'll do them, yeah, what do you turn them in? If that question meant, do I have to do this, then yes, you do have to do that. Yes. Okay, what part?
What you did off to the side.
Okay, are you questions on how I got those 2 numbers?
Yeah.
Is that the start? You're looking for 2 numbers that multiply to this and this. So in this case, 1 times 56 is just the 56. And then it has to add to this middle number here, the negative 1. Then I just started looking at all of my my 56 combinations. And I started with 1 and 56, 2 and 28. And then Maddie said it was 7 and 8 because that was number 28 on the assignment. And so I just jumped to it. And I said those 2 numbers would multiply to a negative 56 and add to a negative 1. We'll do it again on the next problem. Hopefully it will, like, as you see it will get easier. All right, group it. M squared plus 7m, what do they have in common? An m. What are we left with? M squared, m plus 7. From the next group, what do they have in common? -8. You with me? M plus 7. They both have what? M plus 7. And what are my leftovers? M minus 8. Now, there's a shortcut. I'm happy to tell you the shortcut, as long as you don't screw up the not shortcut. So if I tell you the shortcut, can you not screw up the not shortcut? I make no guarantees. Well, do you notice a pattern between the numbers we got on the multiply add game and the numbers that landed right here? The numbers we got on the multiply add game and the numbers we got right here. What are they? The same. So we suspect that whatever we get for this multiply add game, those two will be the same. Let's try it one more time just to be sure. Set up the multiply add game. You are looking for two numbers that multiply to the outside. So this is what you have to memorize. Multiply to the outside. This is just a 1. If that's not a 1, things kind of get a little bit whacked different. Both a 1 times 64 is just 64. Has to multiply to 64 and add to what? -16. Are there any questions with that? I don't have any good answers for you. You just have to memorize it. But multiply to the outside, add to the inside. Then you figure out what two numbers fit that. What multiplies to 64 and adds to a -16. If you know it, don't shout it out. Give people a chance to think about it. What? Oh. Or just say it anyway. All right, who's got it? Ashley, what is that? -8, -8. So we suspect our answers will be x minus 8, x minus 8, right? Based on the pattern we saw in the first two? Okay, let's just make sure it happens that way. So our two numbers are -8, -8. Let's give each of them the variable r and split up the middle term. So r squared minus 8r minus 8r plus 64. It's got 4 terms, so what do you do? Group it. From the first group, they both have an r. From the second group, they both have what? What? An 8. More than that, they have what kind of an 8? A -8. Good. So the negative comes out, the 8 comes out. You're left with r minus 64 divided by 8 is 8. We're on the right track. If you leave, you have to ask permission. Tell me where you're going. And that means bathroom, office. Counseling, like.
Sometimes you can be so sad that you get like physically sick.
It's true. But just a quick, like, I'm going to the office is good.
Yeah.
Yeah. All right. Did we get what we expected to get?
Sure.
I hate that word. Yes? We expected to get, well, I said X, but it's supposed to be R. Beyond the change in variables, did we get what we expected?
Yeah.
Yes. So let's add step 4 to our list. 4. Or maybe it's a 3.5. I don't know. It's a step 3 addendum. I don't know. If A equals 1, what do I mean by that? If I say A equals 1, what do I mean? Phones. Yeah, if I say A equals 1, I mean A equals 1. You're right. It means what? It means that very first number is a 1, right? If I say a equals 1, I mean this number right here is 1. If a equals 1, you can take the shortcut. You can jump to the parentheses. I had a coworker at Westlake, nice man, miss working with him. He had a really hard time staying in his room, so he'd give like 3 examples on the notes, and then he'd just leave, and the students would be there to fend for themselves, which has a perk and it has a disadvantage. Like if they needed help, then he wasn't there, but if they didn't want to do what they were supposed to be doing, then he was gone, so it didn't matter. Anyway, he came into my room quite frequently because he wanted to just leave. He'd just pop into all of the other teachers' rooms and like. He knew a lot of the students because he's the driver's ed teacher, so he'd come in and he'd like give a wet willy to some of the boys, and it would be gross. And like I had his name was BJ. I had like a BJ face print on my window for a long time because he'd just come and like smash his face against it and scare people and think it was funny. Anyway, he came in one day while we were talking about factoring, and he's like, "Oh, it's a hippopotamus bottom." Yeah. So every time I draw it, I think it, and so I like to share it, so maybe you will too. Anyway.
Yeah, I remember that from last year.
Hippopotamus bottom, right there.
What was step 1?
Play the multiply add game. The game. All right, let's look at part D. Knowing that since A is 1, we can take the shortcut. When you're setting up the multiply add game here, this problem looks a little different. What's missing on this problem? The middle term. So I want to multiply to the outside, which is -9, but since there's no middle term, what is that? 0. How do I know it's the middle term that's missing and not the end term?
Because the middle term has one variable.
Yeah, that middle term is the one variable without the exponent. So the first term has to be there, otherwise we wouldn't be factoring, it would already be factored. The last term necessarily doesn't have to be there, but we would treat that a little bit different. This one, the middle term's missing. What multiplies to -9 and adds to 0? -9 and 9 doesn't quite multiply to 9. -9 and 0 does not multiply. -3 and +3. If you multiply -3, +3, what do you get? -9, add them, you get 0. Can I take the shortcut? Can I take the shortcut?
Yeah.
Yeah, so my final answer is what?
B
minus 3 and?
B plus 3.
Do we like the shortcut? Yeah. Good. Next question. What about part E? Set up the multiply add game all on your own. Let's make sure you can do it.
That was exciting.
Okay, we're looking for two numbers that multiply to what?
50 and
Multiply to 50 and add to -15. Do you know what two numbers those are?
Nope.
-10.
Yeah? Can I take the shortcut? Yeah, how do I know?
Because the first number's a 1.
Yeah, does it matter what order those go in?
Actually, it's not even 1. It's just
It is a 1. Doesn't matter. So, X minus 5 times x minus 10 is the same thing as saying x minus 10 and x minus 5. So it doesn't matter. Okay. Rather than having you do part F on your own, let's jump.
Something harder.
Yes, let's jump to the next page. We won't do all of these. Let's pick like, let's do the first 4. How many does that skip? Just 2. Sorry.
C is just like the last 2.
Almost, yeah. What do these have in common?
They're not just one.
It's not just one. But could we force them to be just one by taking out a GCF? So that means if I'm looking at my steps, it says play the multiply add game. Let's add in a step 0 or a 0.5 step. I don't know. You got to look for the GCF first. If you can take out a GCF, it's going to make your problems much faster. So take out a GCF first, and then play the multiply add game with what's remaining. Several people on their phones. Watch your phone usage, please. Okay, on part A, what's the GCF? What do these both have in common? A -5. Now, I want to write it up front like I did last time. What are we left with? X squared. The plus becomes a minus, and 125 divided by 5 is 25. So, after you pull out a GCF, you are going to temporarily ignore the -5, play the multiply add game with what's left over. You are looking, now I wrote that in a box. It sort of reminds you of synthetic division. It's not, just kind of ignore it for a minute. We're looking for 2 numbers that multiply to what? What term am I missing here? The middle term. Okay, so it needs to multiply to the outside, which is -25. Add to the inside, which is 0. What's that one? -5, +5. Every time it has to add to 0, those 2 numbers need to be the exact same number, just opposite of each other. So can I take the shortcut?
Yes.
And then the GCF would come out front. Done. Cortland, how's it coming?
That was
Super good? What about part B?
This is a lot easier this year.
Good. Sometimes time just helps. Yeah. What about part B? GCF? 3. Yeah? X squared minus, keep talking for me. 4x minus 12. Very good. Ignore the 3 for a minute. You're looking for 2 numbers that multiply to what? -12 add to -4. If you can't do it in your head, just start listing things that multiply to 12. So it's gonna have to be 6 and 2. Which one would be negative? It has to be a -4, so -6. Good. And then just check yourself. Multiply them. Do you get the -12? Add them. Do you get the -4? Yeah. Can I take the shortcut? Yeah, even though there's a 3 right here. Yeah, because we're ignoring, I just realized I'm covering it, but it doesn't actually do anything.
Yeah.
We're ignoring that 3, we're left with the x squared, right? So take the shortcut and do what with the 3? Put it in front. X plus 2, x minus 6, with what out front? A 3.
This next one looks fabulous.
What's the GCF on the next one? A -1. So take that -1 out and see how far you can get. So part C.
You didn't put the signs? No, I think we kept it. Yeah. I mean, I. Not quite, you're really close. Your two numbers are a little bit off. Because those would add to 0, not 16.
Oh, I was wondering. Okay.
So take out the negative. We're left with x squared minus 16x plus 64. Set up the multiply add game. Hayden, I haven't heard from you for a while. Like, what would the multiply add game look like?
Multiply
Barney.
64 and 1 adds to negative 16.
Great. What multiplies to 64 adds to negative 16? Negative 8, negative 8. Good. So, can I take the shortcut? Is it important that you ask yourself that every time?
Yes.
Yes, because what happens if you can't take the shortcut? Then you do it wrong. And our goal is to not do it wrong. There it is. Drake? Okay. Now, part D. This one is the easiest problem, but it also is the most missed problem. People try to overcomplicate it. They'll either try to make it look like this one. Does it? I mean, there's similarities between A and D. What are the similarities? Two terms. What are the differences? Barney, head up. The first one's missing the middle term. This one's missing the last term. So what's the, I was going to say very first step, but technically we said it was the 0 step. What's the first thing you do? Check for a what? A GCF. What's the GCF here? They both have, well, negative, 4, and then what else? Y. Okay, take that out. Our goal is to break up the squared. Let's see if taking out a negative 4y will break up the squared. Negative comes out, 4 comes out, y comes out, minus 5. Is the y squared broken down? Yeah, you're done. This is a GCF only problem. You're right. If I were to label something as easy, I would say this is the easiest of everything we're doing today. However, why is it the most missed problem? People overthink it. So, and then I teach it to my kids every year, and I'm like, you're going to come back next time, and you're going to say, I don't know how to do number 1. Everybody look at your homework really quick. Number 1, go. They're going to try to do difference of squares, or they're going to try to do something they're not supposed to. Jake, phone, like backpack. Number 1, what did you get? What'd you get? Number 1. 3x times what? X minus 14. Good. Is there another one that's just like that? Find the next one. Number 5, do it. Guys, when you're asked to try a problem, I need you to try a problem even if it's not right. Number 5 has a GCF. What's the GCF on number 5? You won't learn if you don't try. It is better to try it and get it wrong than to just sit there. The GCF on number 5 is P. Maddie, what does number 5 say?
Number 5 says P is same power plus 4.
Okay, good. So GCF is P. Take it out. You're left with P plus 4. Is there one on your assignment that doesn't have a GCF? Sorry, that doesn't have a GCF but still is a binomial, 2 terms. There's one on that page. Number 9. Let's look at number 9 now. Number 9. K squared minus 9. Now, if there's no GCF, what do you do next? You set up the multiply add game. You're looking for 2 numbers that multiply to the outside, which is what? Negative 9. Add to the inside, which is 0. What 2 numbers fit that category? Negative 3 and positive 3. Can you take the shortcut? Yeah. So take the shortcut. K plus 3, K minus 3. Okay. We do have problems that aren't like four more that I need to get to today. But I'm going to pause for, what time do we get? So the setup on this one's going to be a little bit different. You with me? Everybody get back to their notes, please. The steps are the exact same. The difference with this problem is now we have a coefficient that's not 1 that doesn't GCF out. I just said F out. Anyway, doesn't say GCF, or it doesn't factor out. Okay, cool. So you set up the multiply add game. This time, when we're looking at the outside, we have to look at the 6 and the 5 together. Multiply those 2. What do we get? The best part is, I just said that on the recording. Has to multiply to a negative 30. And add to what? The middle. The only difference is we have to pay more attention to the first number. It has to be this part. And then we can't take the shortcut because the leading number is not 1. So you're going to have to force it into 3 terms or 4 terms, and you're going to have to group it. So what multiplies to a negative 30 adds to a negative 13. If you don't know, you start listing what multiplies to 30.
I have a question.
5 and 6.
Are
Yes.
those 2 variables supposed to be different?
Oh no. Should we work with ends and not a's?
Yeah.
Yeah, sorry.
Wait, hold on.
No, that's a typo that keeps following me because these were the same notes that I used in secondary 2. Still a typo. I'm pretty sure I used them when I was at Westlake. Still a typo. All right, which 2 of those would add or subtract to 13? Now you've got 2 numbers that are really close. It can't be both of them. Which one is it? 2 and 15. Because of the negatives. Which one would have to be negative? The 15. If I multiply them, do I get a negative 15? Yes. If I add them, do I get a negative 13? Yes. Can I take the shortcut? No. So let's regroup things. 5n squared plus 2n minus 15n minus 6. Then once I get them into 4 terms, what do you automatically know to do? Group it. That's a plus. From the first group, what do they have in common? An n. What are you left with? From the second group, what do they have in common? A negative. Not 5, but that's what you would get once you divide the GCF out. So it would be what? Negative 3. So the negative comes out. 15 divided by 3 is 5n. Turns into a plus 2. It's really important that you actually divide this out. Even though I know they're going to be the same, still do the division because that is a way that you know that you're doing it right. Okay, what do they have in common? And what are the leftovers? This is the correct answer. What answer would you have gotten if you took a shortcut? If you jumped straight to factored form, it would have been what? N plus 2, n minus 15. Are these the same numbers? Are those the same factors? No. So this does not work. You can't take this shortcut. Okay? So one extra step. You got to make sure that 5 is taken into account. Yes?
It doesn't matter which one goes first, right?
Not at all.
Where did you get the, oh, no.
Okay. Any other questions? All right, on your own, try part B. Set up the multiply add game. You're looking for two numbers that multiply to what? What two numbers multiply to what? -8. And they have to add to what? 2. We are part of the course that this unit is going to build. Last year I had one student in particular that kind of like pieced out at this unit and then pretty much played catch up for the rest of the school year. Really struggled through unit, in this case would be 6, really struggled through 7, really struggled through 8 because they just didn't try in this one. Like we're getting to the point where, I mean, unit 1 and unit 2, if you didn't get 1, unit 2 didn't matter based on 1. And if you didn't get 2, you still could do 3. But now we're on unit 5. And unit 4, we're actually building on that one too. If you struggled dividing, we're going to see it again on Monday. So they're starting to build, and it's going to make more of a difference that you're doing everything you need now so that in future sections, it's not going to be so hard. Are you okay with this setup? What multiplies to -8 adds to 2? 8 doesn't have very many choices. So it's got to be this one. Which one's negative? 2. Can I take the shortcut? All right, minus 2x plus 4x minus 1. Now what? Group. From the first group, what do they have in common? This is a really good question. A lot of people make a mistake with this grouping problem. They both have a 2x, right? So what are we left with? 4x. Is it just a 4x? A 4x minus 1. Because if you divide each of those out by a 2x, you would get a 1 here. What do they have in common here? A 1. That's it, just a 1. You put the 1 as a placeholder. So this is an easy place to make a mistake. This is an easy place to make a mistake. Did I get the two pieces the same that need to be the same? Yeah, so 4x minus 1 and 2x plus 1. Rather than doing the next one in your notes, why don't you try number 19? Adriana, will you read 19 to me really quick on your homework? Okay, cool. Set it up. Try it. Two numbers that multiply to what? I'm looking for two numbers that multiply to 12. Good. And add to what? 7. Go. You're looking at number 19 on your homework. Please try it out. What are two numbers that multiply to 12? What two numbers work?
3 and 4.
3 and 4. Can you take a shortcut? No. So we say, let me just back up a little bit. Two numbers that multiply to 12 add to 7. The 12 we got because we multiplied those two together. 7 we got because of the middle. 3 and 4. So 2n squared plus, does it matter? Yeah? Anybody switch those in different order? Anybody do this yet? You switched them? That just means this step right here for you is going to be backwards, but your final step should be the same if you switched them. So group, from the first group, from mine, what do they have in common? An n, right? What are we left with?
2, 1 plus 3.
And on this group, what do they have in common?
2.
A 2. Leftovers?
2n plus 3.
They both have the 2n plus 3. And final?
N plus 2.
You got this. Okay.